Today we're looking at Glencoe Accelerated Math, Lesson 7.5 on distributing a linear expression. Factoring a linear expression. We already know how to distribute. When we distribute, we take a number outside of a set of parentheses and we multiply it by everything inside. Because that number outside tells us how many sets of that quantity inside of the parentheses we have. When we factor, we're doing the opposite. We're taking that form of the expression. We are factoring out a common factor. And then what's left goes inside of our parentheses. This lesson also talks about finding the greatest common factor between two what we call monomials. That is an algebraic term that only has one variable typically, and there are no exponents. Okay? As we factor the expression, we have to find the greatest common factor. So we're going to do those two things together today. If we're asked for the greatest common factor, we're asking for what is pulled out between those two quantities. Does everyone understand that? Okay. So let's start with the factoring part. There are two different ways that we can do this. I'm going to show you both ways. You can choose which way you prefer to use. Both have pros, both have cons. So it's really personal preference. Okay? Mentally is not an option. So I'm going to divide my board so that we can do both methods. If we start with example 2 on page 317, we have 3x plus 9. Please stop. $3x plus 9. The way that they show you in your book and the way that most of us would solve this says that we list out our factors of each term. So our factors of 3 are 1 and 3. Our factors of x are 1 and x. Our factors of 9 are 1, 3, 3, and 9. We're going to write the 3 twice because we have to multiply the 3 by itself to get to that 9. Okay? Then, to factor, we take the greatest common factor between them, which would be 3. And that 3 will go outside of our set of parentheses. The partner to what we had will go inside the parentheses. So, I like to do this first. Circle the greatest common factor. So I circle my 3 and my 3. If these two numbers are the same, does it matter which one you circle? No, just make sure one of them circled. Okay. Then I'm going to put a box around the partner or the pair of that we still have to have so that when we multiply it back, we get our expression we start with. So 3 partners with my 1, and I still have to keep my x. We can't eliminate the variable. 3 partners with 3. Then my circle will go outside a set of parentheses. And then I look at my boxes. I have a 1 and an x. If the 1 is a coefficient for my variable, do I have to write the 1? No. So I can write the x. My operation is to add, so that comes down. What got partnered with the 3? 3. So the factored form of the expression, 3x plus 9, is 3 times the quantity x plus 3. If you distribute, do you get 3x plus 9? Yeah. If we distribute this and we say 3 times x, we get 3x, and 3 times 3 gives us 9. So the expressions are still equal to each other, they're just written in 2 different forms. Okay? Any questions on what we've done so far? I'm sorry?
I was going to say it's just the same thing.
Right, we're just writing the expression in a different form. Just like when we combine like terms, the quantity that we have doesn't change. We're just writing it in a smaller form. We're writing it in a simpler form. Okay? When we work with expressions, we can't change the quantity that we have. We're simply rewriting what we're given. Okay? Any other questions? Okay. Here's the other way we can do this. The other way, I like to call it the upside down cake way. Upside down cake.
What?
Hold on. Hold on. Because it kind of looks like a tiered cake. So we start with a box and our expression in the box. Now we have to think, what is a common factor between 3x and 9? It doesn't have to be the greatest common factor, but we need a common factor besides the number 1. 3. We'll write a 3 below. Here's where the upside down tier comes in. We draw another box. What times 3 gets me 3x?
9. 3x.
What times 3 gets me 3x?
3.
3x.
Guys, hold on.
XYZ.
What times 3 gives me 3x?
X.
There we go. Okay. You had me scared there for a second. What times 3 gives me 9?
3.
Okay. So, while my rectangles are not drawn, centered, it looks kind of like an offset tiered cake, right? Okay, that's why I give it that name. We would write this in mathematical forms as 3 times the quantity x plus 3. Because we cannot factor anything else out of the x plus 3. If there is something else that could be factored, we'd add another row. And then we multiply the values outside by each other. And I'll show you an example of that in a couple minutes. Stop. Any questions about what was done? Pros and cons to each. This way also shows you your greatest common factor quickly. This one gives you all of your common factors. Okay? This is what you'll see more often in a textbook. It's a little bit more academic. Okay? This way is great if you're not good with your factors. If you know that you can find a factor but not necessarily the greatest common factor because you might miss something, you can do it this way. However, at the same time, if you don't remember to go back and double check what's inside your box for common factors, you could end up getting something wrong because you forgot about a factor. Okay? So like I said, there's pros and cons to each. You have to make that decision about which way you use. Either way, we can find the greatest common factor because the greatest common factor is a number outside of our parentheses. Either way, you're showing me what you're doing, so you're showing your work. You can't eliminate that part. You have to show me your work. Both ways end the same. Okay? Questions? Okay, let's look at another example. I'm looking at page 318, and we're given that the garden at the right has a total area of 15x plus 18. Square feet. Find the possible dimensions of the garden. So, therefore, we have to factor 15x plus 18.
At this time, all green team students, please report to the gym. All green team students, please report to the gym.
Okay, so if we list out our common factors here, we have 1, 15, 3, and 5, correct?
Yes.
Those are my factors of 15? Okay? My factors of x are still 1 and x. My factors of 18 are 1, 2, 3, 6, 9,
41.
and 18. Am I missing any? I have all my factors listed?
Sure.
Okay. What is my greatest common factor between 15 and 18? 3. So I circle my 3. What gets partnered with the 3 to get me up to 15?
Another 3.
5.
Another one.
What about my x?
6. Okay.
Right, I have to box my x.
Box it.
What gets partnered with 3 to get to 18? 6. So that gets a box. My circle goes where? Circle goes inside or outside the parentheses?
Outside.
Outside. We're still adding. If this was a subtraction sign, what would we do? Subtract. Or you could KCA it, either way. Okay? Inside my parentheses, I end up with what? 5
And 6.
And 3.
5x.
And 3. And 6.
5x plus 6 goes in my parentheses.
And then that's just it.
That's it.
Oh, wow.
Okay? Remember, we are either doing it this way or you do it this way. You don't have to do it both.
What's this?
Okay?
This way is much more simpler.
What?
The way we just did it is much more simpler.
I feel better.
Like I said, there's pros and cons to each. There's 20-something people in this room. Okay. Stop. We're not counting. We don't need to let people watching the video know exactly how many people are in the class. And I bet if we took a poll later, we'd, have some that preferred each method. That's okay. You just have to know one. So if I do my upside down cake over here, I start with 15x plus 18. Okay. What can I factor out of 15x plus 18?
15.
I'm sorry?
3.
3. I can factor out a 3. Okay. I'll make my cake a little prettier this time. What times 3 gets me 15x?
5. That's
5 what?
5x.
5x. What times 3 gets me 18? So, writing in appropriate mathematical form, 3 times the quantity, 5x, plus 6. Questions? Okay. What was the greatest common factor of both of these examples? 3. In both of these examples, it just happened to work that the greatest common factor was 3. If you have situations where both terms have a variable, you can even factor out a variable. So if we had 3x plus 9x, we could factor out a variable. You could factor out x. If we had 3x plus 9xy, we could still factor out the x. The y would be left, but we can pull out the x. Okay? Alright, I would like to do one more where we have multiple
At
common
this time, all
factors.
gold team students, please report to the gym. All gold team students, please report to the gym.
Okay. So, one last example. If I have
What are you doing?
32 plus 24y.
Why are you doing
No, I wanted 36. I'm sorry. Because we can also factor with our variable term second instead of first. We know that this is less grammatically correct, but we can see expressions like this. Okay? So, using this format, I'm going to change the marker color so that it's a little bit easier to read. What are my factors of 36? We can start, let's start this way. What are so give me a set of factors, not
36.
4 and 9? What is that?
1
And 17.
and 36,
4.
2 and what?
2 and 13.
2 and 18. 13 would give us 26. We need 36.
3 and 12.
Okay, 3 and 12.
4 and 9.
6 and 6. And then 6 and 6.
Okay,
Which time?
excuse me.
Wait, but you only do 6 one time.
We need the 6 twice because if 6 is our greatest common factor, we need 1 to circle and 1 to box.
Okay.
Okay? Alright, factors of 24 are 1 and 24,
2 and 12.
2 and 12, 3 and 8.
4 and
Okay,
And then
factors of y,
Y.
1 and y. Okay? What is my greatest common factor between 36 and 24?
6.
No.
12.
12. What partners with 12 to get to 36?
3.
3. What partners with 12 to get to 24? 2. What about my y?
1.
Y.
Why?
Okay. So, somebody tell me, how do I write this in factored form? Yes, sir.
Well,
Y on the outside.
Y on the outside?
Or, Z on the outside. Wait. Hold on. 12 on the
12 on the outside. Why is 12 on the outside?
Because it's the pair that we or the two.
It's the GCF.
Yeah, the GCF.
It's the GCF. It's the greatest common factor. That's the part that goes on the outside. What's circled goes on the outside. Okay?
Okay.
What goes on the inside then?
The box.
3 and
3
Y.
2 1.
Okay. So, we have
At
3
this
plus
time, all
2y.
8th grade students who are in elective classes, please report to the gym.
3 plus 2y goes inside my parentheses. Okay? Everybody good? Do we see where here it's easy to see what our greatest common factor is? But we have lots of common factors, correct? Okay. I'm going to show you where,
Are you?
and we're going to intentionally not use 12 as the factor we pull out right away on my upside down cake. Okay? You're not allowed to use 12.
That's my age.
So, I have a couple people that need to redirect their focus.
Come on, dude.
Sorry about that. Thank you. Okay, so without using our our greatest common factor of 12, what is a common factor between 36 and 24? Yes, ma'am. 6. Okay? What times 6 gives me 36?
6.
6? What times 6 gives me 24y? 4y. Can I still factor something out of 6 plus 4y? Yeah. What?
2.
2. Okay. What times 2 gives me 6?
3.
What times 2 gives me 4y?
2y.
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 You can't forget about your variable. I even tried to add in an extra one just because I felt like it.
Yeah,
Why?
You guys caught me. Why can't we forget about our variable?
why?
Because if we leave out that variable,
Why?
then we would just have 3 plus 2 as terms that I can combine,
Why?
and we would end up with 10 here. But I don't have 10. I have
Why don't you have 10?
3 times the quantity, 3 plus 2y.
Why?
Oh.
Because I have 2 of the number y that's unknown. I don't know what that quantity is. But unless y happens to equal 1 and we're not told that, then this, if we simplified it, is not 10.
I get it.
And I can't say that because I don't know what y is equal to. So we have to keep our variable there. Okay?
Right.
Alright. Can I factor anything else out of 3 plus 2y? Alright? So 3 plus 2y,
Wait, what happened to 12 on the outside?
our 2, our factors on the outside, we multiply together. That gives us our greatest common factor. So the 6 times the 2 gives us 12. That's where we get the 12 on the outside from.
That's insane.
Okay? So instead of 6, if we had used 3, we could use 3 and 4. We could use 3, 2, and 2. Any of those common factors and factors of those factors we can use.
Why?
And we'll eventually get there this way. Okay? Does that make sense? So, in our first 2 examples, we only had one common factor. And that was our greatest common factor. So our cake only had one tier. You can have multiple tiers. The number outside is the multiplication or the product of those. Okay? What questions do we have? All right, thank you.